And so just a quick introduction. Michael's from Washington University, and he's going to be doing a case study on supporting large computational data sets with MIRRIR, the image repository that we have. I will go ahead and let him take over now.
All right. Hey, everyone. Can you see my screen? All right. So, as Josh said, I'm Michael. I've been lurking around in this group for, I think, maybe 9 years at this point. So I'm sure I've met many of you. I'm going to talk to you today about MIRRIR. So it started a couple of years ago. Dan and Jenny Gurney and Pam Lamontagne kind of did the planning aspects, and then brought me on as a programmer to sort of see some of the stuff into bring it into fruition. So as Josh said, it's the Mallinckrodt Institute of Radiology Research Imaging Repository. Quite a mouthful. And while I love the acronym, after 2 years, I now cannot spell MIRROR with an O anymore. So, but that's okay. So we're going to go into kind of an overview of the data, both on the clinical side, just to give you an idea of what we're dealing with, and also what we have within our XNAT. And then requests, and that's kind of the anatomy of a request from my perspective of how we get different requests from researchers, how we're currently doing cohort discovery, some of the automated processes that we use to do that, get slightly detailed on the infrastructure aspects, not too far, and then also talk about some of the plugins that we've used and developed specifically for MIRRIR. And if we have time, we'll talk about kind of where we're looking to go next. So first, real quick, MIRRIR, it's kind of a name, for the project and the whole ecosystem, but then it's also the name of our XNAT instance. So I'll try to be clear, when I'm talking about which aspects. So what we're up to is getting all of the radiology exams, all the DICOM images, and their associated reports from the BJC academic hospitals, and then WashU investigators can conduct research and develop computational algorithms for various disease prediction, diagnosis, treatment guidance. So this is currently only available on our network or through the VPN. So we have what we're calling the MIRRIR back office, which is sort of it's this middle section here. It's where we're retrieving the clinical data, doing anonymization and staging things to deliver to authorized users. And I'll expand on these parts more later on. And so once the images are anonymized, we send those to our research XNAT. And also we send along the radiology reports as well, so that they can be used alongside the imaging. So we have, we use the OHIP viewer pretty extensively in our project. And then we also have a compute cluster that's available to us. It's a Docker swarm that we're utilizing at this point that has some GPUs. So, the point of sort of having these two separate areas, the back office and the research side, is to limit access to just a couple of admins to the sensitive clinical data, but then open up all of the anonymized data to a broader group of researchers. So here's what we're looking at on the BJC side, Barnes-Jewish. So as I said, it's just the academic hospitals, which is Barnes-Jewish Hospital, St. Louis Children's, WashU School of Med, and Siteman Cancer Center. So they're at about a petabyte of imaging data, and obviously growing. These numbers look similar actually to Chris's talk with Mount Sinai, about 2 million patients, 20 million studies, and over 100 million series that we've sort of indexed from the PACS at this point that we can search across. And then we also are getting the radiology reports and clinical observations from HL7 messages, also a feed that we get from BJC. And that's coming in at about 5,000 messages per day. So there's a lot coming at us. This screenshot here is the Kibana interface that Dan had brought up previously. And so from there, you know, again, these are kind of from my perspective how I get different requests. You know, the easy one obviously is just somebody coming with the specific image identifiers. You know, easy for me, it's usually painstaking on their end. Maybe they had to go, you know, review medical charts in Epic or something like that. There are also other external research databases that people kind of already know exactly what imaging. Then the interesting ones for us are, you know, someone comes with a list of patients that they know they want as their cohort, but they don't really know anything about the imaging yet. So we can do things like, you know, we can focus in on modality, series description, body part, so on and so forth. And also we can look at the clinical observations and reports. We can actually do full text searches on the reports. And then other useful things like ICD-10 codes or diagnosis. And then there are also just kind of general requests, you know, no specific patients, you know, so this is similar to two, but you know, you might want all brain imaging or all CTs, chest CTs from a particular year up to a certain amount of studies. So one way we do this is still in a, you know, sort of directly querying the packs. We're still using the DIMSI services, so not you know, this is pre-DICOM web. So we're using tools like the DICOM toolkit and doing cfind, cgets, etc. And then also PyDICOM, and I just recently started using a library PyPX, which builds on top of DCMTK and PyDICOM. So you see we can feed this script an input CSV. It uses the regular cfind syntax, so you can look up wildcards on particular fields, you can do date ranges, and then this just does a query directly against the clinical packs and gives us a list of study instances that we can then stage for a research aim. Oops. And then back to again, kind of a more interesting way to do this is this elk stack that we built, and that's what Kibana is part of. So it's Elasticsearch is the data store. Logstash kind of is the aggregator in this case, and so we store most of this clinical data actually in a clinical instance of just a Postgres database. So Logstash can do SQL queries and join across different tables, so that you could build Elasticsearch indexes out of that. So what that gives us is, you know, directly in this filter area, the search bar, we can do similar searches, saying, you know, give me just CT modality, you know, for this date range, and then, you know, do some searching on body part and study description, for instance, to sort of pin down exactly which images you want. And then now we're actually over to the XNAT side of things. Well, quickly, right before we have about 100 terabytes of fully identified clinical imaging, and since you know the aim is to get the whole hospital, we're also expecting, you know, about a petabyte of data, and we currently have about just 300 gigs in our XNAT archive, and you can see here these are the numbers for the MIRRIR XNAT instance. It's getting up there, you know, almost 250,000 subjects, over 250,000 image sessions, a couple million scans. So we're dealing with that scale that you guys went over so well in the previous roundtable here. So, and you can see some of the areas of research that we've currently dealt with. So we've fulfilled about 20 requests at this point, and it's fairly varied from COVID-19 diagnosis to different NLP algorithms, other studies using the OHIF image viewer to do some trained learning. And so here's the more detailed. These are what I had earlier in the slides. Just kind of exploded out a little bit. So as I mentioned, we're using the DIMSY services. We're really kind of excited to, and hoping to get the DICOM web from the BJC IT team in order to start utilizing that. I think that'll be a game changer for us. Because we're currently, let me start here. So some of our automated processes that we're doing, if you focus in here, we're doing just loads and loads of cFinds basically to index this thing. And we can certainly keep up on a daily basis. It took months to do it retrospectively back to, roughly the year 2000. So what we do first is we do cFinds on all of yesterday's studies. We generate our unique MIR IDs for that. And then we also do series level cFinds to get DICOM metadata, which we're then storing here in this Postgres database. And then we're also bringing in, like I said, the radiology reports and clinical observations and into this same database, which then allows us to join across these two data stores, which is pretty powerful for cohort discovery. Now if we follow sort of how the imaging flows, we request a CMOVE from the PACS, from the clinical PACS, which comes to our back office area, fully identified on top of, sits on ZFS storage, which Chip has outlined some. And then we're currently using CTP for this part of the operation. I think really soon we'll be moving to DQR, but 2 years ago DQR wasn't quite where it is today. So we started with CTP and are pretty excited to move forward with DQR though. So these are basically steps, the store to file system decompress. So anyone familiar with CTP will kind of recognize these. And so at the end of that, we're sending, doing a DCM send to our XNAT instance. And the way we're currently storing, XNAT with its project based data model, that would put, you can't just have one kind of source project, or at least I haven't found a way to do this without kind of upsetting the file system. File systems and network clients don't like to have really leafy branches on one layer. So I'm currently splitting these up by study date into sort of year-month projects. And the point of we want to stage all of the imaging possible kind of as fast as we can get it, because when we move to these research projects, we want to be able to kind of have that deployed and available for research as soon as possible. And this will help for researchers, as well as as you guys were talking about some of the stuff that will become more and more automated. We don't want to have to do big data transfers constantly. So back to the ELK stack and how we create cohorts from this is with this joined clinical data, the DICOM metadata and reports. We're able to do some of those queries that you saw where we can, it'll output our list of studies we want, and then we send a request to XNAT, and this will go ahead and build these research projects that we can then give access to the PIs, and then they have control of co-investigators who they can give access to. I'm not necessarily recommending our current method, but we're using file symlinks to try to speed some of this up, and to reduce just copies of data being everywhere. So we use we have a custom plugin that will actually just go and copy it will copy the XNAT object in the database and symlink all the files. And to the XNAT user, they have no they can't discern whether it's a file or not until you actually get on the file system. And then so we also have the container services, which will be talked a lot more about it, Matt Kelsey, and maybe a roundtable on it. But we're utilizing that. So the researchers within their projects can, we kind of work with them to containerize their algorithms they've come up with, and then we can submit those containers to our Docker swarm with GPUs, and then results say back to the projects. We've kind of adopted, we're currently storing most of our ML output as XNAT custom variables. I don't know if that's the best way yet, but it sort of keeps everything in one table. And our hopes there are to be able to join this output back with the clinical data as well, and hopefully solve some of the issues of now you could do, with cohort discovery, you could find a cohort and also filter on these different machine learning outputs. So that's sort of work in progress right now. I kind of talked about the image linking plugin already. And we used the OHIF viewer extensively, and Dan has mentioned Woon Chan's Rapid Reader, which is just a nice focused way. Both from an administration perspective, you can sort of limit what people are looking at and doing, and it's also a nice focus for the individual reader as well, to define a work list that you go through instead of having to click around in a broader UI. And then Woon Chan's also working on an HL7 import plugin, so that we'll be able to go directly from this HL7 feed into XNAT. So will likely actually export HL7, I think, into multiple places. So some of the challenges that we've come across that we'll talk about as we go along. The throughput from BJC long-term archive was a hurdle first and foremost. We were able to get multiple PACS AE titles, and there are multiple servers. MIRRIR, the different kind of MIRRIR instance of the long-term archive. So we were able to get access to all of those, and then also they allow us to run a certain number of threads. The XNAT import and session builder, really large number of images, not necessarily the size of them, but it's almost more smaller images we tended to have issues with, x-rays and such, where we would kind of clog up the pre-archive. So again, one way to alleviate was to use symlinks for the research projects. And we also added an active MQ server, which not only decreased the errors that were causing us to have to restart and rebuild, restart Tomcat and rebuild our pre-archive, which is an XNAT setting. And it also increased the throughput, even without the error. So I think I had something like a 3 or 4 times, I think, increase. Symlinking, we still having challenges with it. Containers aren't resolving them. I think for one, we're using absolute symlinks as opposed to relative, so on and so forth. So again, we might be rethinking how we're storing this data, in terms of whether we may bump the XNAT team and see if we can think about a different way to actually spread things out in the archive. So some of our ongoing efforts on the HL7 front, we are wanting to add in a MIRRIR Connect or Next Gen Connect, previously known as MIRRIR server, which will allow us to take these messages in from the hospital and send them to multiple databases if we want. So directly to XNAT will be one place that we take the reports in. And then again, excited about DQR. We currently store all of the clinical imaging on our file system, but we may, if we could get the right throughput directly from the hospital, we may be able to cease actually storing everything, and it's only store the metadata, the clinical metadata, but leave out the pixel data. And I think that would be an improvement. DICOM web. I don't know how many times I've sort of been pining for that through the talk here, but I think that would be a huge benefit for imaging metadata, as opposed to having to do multiple cFinds. We could just do things at the study level, and we're looking into kind of a SQL query engine to help extend our cohort discovery. And this would just be another way to kind of combine multiple data sources. So including our XNAT database, we could sort of index our Elasticsearch. We could throw into it. We could throw our clinical Postgres database. And then with some of these SQL query engines, you can then join across all of those. And something I heard you guys talking about in the last panel was sort of visualizing, how do we want to visualize this stuff at the project level, and aggregate data and get maybe more charting involved. So we're looking into that. Of course, we're excited about the XNAT 183 upgrade being in arm's length, arm's reach of the XNAT team. We usually stay pretty bleeding edge. So I no spoilers, but so then there's a direct to archive feature that I see is coming out that we're pretty excited about. And that's going to allow us to save a ton of disk IO, I think, and not have to copy things from the pre-archive to the archive. We can just kind of go straight to it. And that's what I have. So I'll try to get to these questions here. And then also, I don't know if I mentioned, I do have a poster session tomorrow. So if anything I don't get to today, I hope you come and join me there. And you could also send me an email. You can bother me whenever you want. And if you want to send something along and you might want to chat about tomorrow, we could do that. So what do we have here for questions? How do you profile incoming studies into a specific XNAT project? Stepping away from CTP to utilize DQR, how do you envision profiling incoming studies? So right now, that's kind of a part of our cohort discovery process, where we come up outside of XNAT with the studies that we want, and then that's the list that we hand to CTP. So it would sort of be the same with DICOM query retrieve plugin. You can do bulk uploads with DQR, which I'm sure they'll get into. The Rapid Reader plugin, someone asked, where can you download DQR and Rapid Reader? The Rapid Reader plugin isn't available yet. Someone can correct me if I'm wrong. Woon Chan Cho will be doing a poster session tomorrow on the Rapid Reader specifically, so you'll want to show up for that. Let's see. Misha's asking if we routinely collect or plan to collect additional information, such as clinical encounters or non-imaging lab reports. We always want to. I think we would take as much data as we can get access to. Being Institute of Radiology, I think we're trying to make sure that we can handle the imaging and the radiology reports really well before we take on too much other clinical data. But yeah, of course, we would love to get as much as we can. Ivan asked if I can talk about how we archive the data. So yeah, we're doing using CTP, we're doing the DICOM send step at the end, which sends it to our DICOM SCP receiver. It's you know, at least in my experience, it's kind of a pretty standard way to get DICOM imaging into an XNAT. So if you meant something more specific than that, just let me know.